Hello guys, what's up? This is Mortaza. Welcome back to a Coder's Journey. This is the next episode of our Object-Oriented Programming in C# series, where we are talking about the fundamental concepts of OOP and how to implement them in C#. I hope you have already watched the previous videos because as before, whatever I talk about in each episode is kind of based upon the ideas of what I've already covered in the previous video. So I think it's best if you go over the videos in order. In the last episode, we kind of talked about access modifiers and the fact that they are useful for implementing encapsulation in C#. And in this video, I have decided to talk about properties, right? Another way to implement encapsulation. And basically, encapsulation is protecting the data integrity of your objects, right? The data that are stored in your objects need to be protected. You need to, limit access from outside of your class, right? Using, for example, private access modifier, and properties are yet another way to implement encapsulation. Now, first let's talk about properties, then we will go to Visual Studio and see how they are implemented. So, yep. Encapsulation, as I told you, is a fundamental concept in OOP, and it involves bundling the data, properties, fields, right? Or not properties, fields or attributes, and the methods that operate on those data in a single unit known as a class. So using encapsulation, you are kind of bundling related data, related fields, and methods or behaviors to one another, things that are closely related. I think you can watch one of my videos on clean code principles about code cohesion in the playlist that I have about clean code. Now, the idea for encapsulation, right, or behind encapsulation, is to protect or hide the internal details of the class and provide controlled access to the data. So you're not gonna give out full access, right, or uncontrolled access to the consumers of your class, right, to the people or other programmers or other applications who are going to use your classes. You're not going to give them full access, uncontrolled access. You're going to control their access. You're going to hide the details that they do not need to have access to, right? Or the details that you consider to be sensitive. So properties in C# play a crucial role in achieving encapsulation, and we will see how. Properties in C# are a way to expose private fields. So basically, we will declare our fields as private, right, while controlling access to them. And then we're going to give controlled access to the consumers of our class, right, using properties. A property is like a combination of a variable and a method, and it is typically implemented using two methods, right? A get method, which is somehow called getter, and a set method, which is sometimes called a setter method, right? And the get method or the getter is responsible for retrieving the data which is stored in that field, in that backing field, in that private field, right? And the setter method or the setter is used to assign a value to that property. Before going to Visual Studio, or let us do this. Let us go to Visual Studio, right? I will show you how to implement properties, and then we will come back again to the slides because I want to talk about something important before wrapping up this video. So guys, here I am in Visual Studio. I have created another project in this solution, episode 7, right? And I want to talk about properties. Let's create a class. I'm going to call this class person, right? I'm going to choose public. And so far, what we have seen is to declare our fields as public. So I'm going to say int, let's say a string, right? Name, right? And I told you that we can have a constructor, right? So I'm going to say a string name, right? And then I'm going to put whatever name is to this field. And then basically I can come here and I can say var person equals person, and then I can put in my own name, right? And this is very good so far. And then I can, print out the name. So let's see what happens. I get my name, right? Now, this field is private. So I am giving a full access from outside of this class. This is another class. This is my own person class, right? So basically using a field which is created using public access modifier, I am giving full access to the consumer of my class, right? So the consumer of my class is able to put in 1, 2, 3 as the name. And then you see name is set to 1, 2, 3, which of course doesn't make sense, right? So encapsulation is about, as I told you, protecting the data integrity of your classes. So basically you are bundling the data and the methods, the properties into one class, and you are protecting, you are hiding basically the internal details. So some more often than not, that protection I'm talking about is implemented by hiding the internal details of your class from outside, and limiting access of the consumers of your class to the internal details. So if I want to implement properties, right, in order to protect this piece of data, this name, the first thing is to declare this as private. You remember private, right? So when I declare this as private, it means that from outside of the class, I cannot set or I cannot get the value stored in the name, right? Because this is private. And the convention is that when you have a private field, right, you need to kind of change the signature or the name and write it as the camel case, not Pascal case. So camel case means that all the letters of the first word are in lowercase, and for the other words, right, the first letter is only in the capital. So I'm gonna get rid of this for now. And you see I have another error here. It says that name is not no, it doesn't exist because I renamed this, and in order to help Visual Studio, I can say this.name. When I say this.name, it means that the name that is declared at the class level, not the input parameter of this method. This is somehow to clarify what name we mean, because the field, right, and the input parameter have the same name. When I say name equals name, Visual Studio, has a hard time understanding what we mean. But when we say this.name, we are clarifying this, right? So first off, in order to include or implement, encapsulation, I am limiting direct access to this field, to this string field. How? By changing a public modifier to private, and then I'm gonna introduce, a property. My property should be of type a string. It is public, and then it has a similar name, right, to my backing field. This is sometimes called the backing field, right? And then, as I told you, we can have two parts, a getter and a setter. So a getter is used when you want to get the value out of this, private field. And then you have the setter, and the setter is used when you want to set a value to this private field. So the setter here can be written, the body of the setter can be written like this, because we want to set a value, right, to this backing field. We can say this.name, or name in this context, equals value. And value here, you see Visual Studio has turned it in blue, right? It is an implicit keyword, which means whatever value is going to be set in the property. So here, for example, if I come here and if I say person.name equals my own name, this will be set into the value that we see here. Why? Because we are setting something in the name property of this object. So whatever you kind of put on the right side of the equals operator when you are working with a property, this value is put here, right? So when we say name equals value, it means take whatever is on the right side of the equals and then put it in the name variable here, this field. And when you are working with get, you can say return name. So whatever is stored in this name, just get it and return it, right? So when I say, for example, var name equals person name, it means it is kind of invoking this piece of code is invoking this get part, right? And this piece of code is invoking this set part, right? This set part. And of course, I can, comment this out, right? And I can come here and implement this myself. I can say I have a set property, for example, set name, right? Which is gonna take in a name, right? And then I'm gonna say name equals whatever we have in the input parameter. Of course, I need to clarify this. And then I can have another public method, public string get name, right? And then I'm gonna say return name. So basically, I can do it myself. I can implement this set name and get name part of the property myself. And I think in Java, we do this, right? But in C#, we can get rid of this and we can work with our properties, right? So I'm gonna uncomment this. And here, instead of working with my field, right, I am working with my property from now on. And basically, right now, still I can set a meaningless value to this name property. So whenever I run this, you can see that the property is set to 1, 2, 3, or rather the banking field, right? But it doesn't stop here. Using properties, as I told you, you can implement encapsulation. You can, for example, protect the value which is going to be stored in this banking field. For example, in the set part, you can add some validation, right? You can say, for example, if suppose we want to, for example, protect against setting a string null or empty value. So I'm going to say if string is null or empty value, if value is not null or empty, then go on and set the name to value. Otherwise, don't do that, right? Or you can say, for example, otherwise name equals default value. And I can also, add some braces here to make this easier to understand, right? I can get rid of this piece of code. I can do this, and basically I'm gonna take this part and put it in the braces here, right? I'm gonna format my document. So you see in the set part right now, I am putting in a simple logic in order to protect the integrity of my data. So if, for example, here I try to put in a string, an empty string, right, to this name property, let's see what happens. If I run this, you see, because I am trying to set an empty string to this name, the output, the default value, which I set here, is going to be set, right? But if, for example, I come here and I say, no, I want to put in my own name, and then I run, I get my own name. So using properties, I have somehow, at a very basic level, achieved encapsulation. So I am protecting the integrity of my data, and I am kind of bundling the data and the behavior which is working with that data in one single place, which is the person. So as I told you, properties can help us achieve encapsulation. Now I want to take you guys to a PowerPoint, to my slides one last time, and tell you a couple of things about the benefits of properties and then finish this video. Now let's continue here in the slides, right? So we talked about properties and encapsulation. Let's summarize what we talked about in this video. Encapsulation achieved through properties, right? There are many benefits and advantages. First, better control. It provides better control over class members. You saw that, right? Instead of working with fields, giving full access to the consumers of our classes, we are controlling the access. We are controlling the values which are going to be set in those fields, and we are reducing the risk of unintended changes to the code. We can declare, that getter method, that setter method as private, or we can also omit them. So basically, that can help us to have read-only properties or write-only properties. When, for example, we want to have a read-only property, all we need to do is to get rid of that setter part, that set method of our property. So properties can be configured to be read-only using only the get method, or write-only using only the set method. So this is very convenient. It gives us, flexibility. Now, the next one is actually flexibility. The programmer can change one part of the code without affecting other parts, enhancing code flexibility. For example, you can change the name of your backing field without having to change the name of your property. So basically, you have decoupled, right, that backing field, the name, and the name of the property. So you can make some internal refactorings without affecting the consumer of your class. Increased security. It enhances the security of your data by controlling how it is accessed and modified. And I told you about this, right? We are protecting the data which is going to be stored in the fields. Whenever some data is going to be stored in the field, in that setter method, we can, control the data. We can inspect the data, and if, for example, it is null or empty, we can, for example, set a default value to the backing field, and so on. You get the idea, right? Thank you so much. I don't want to, oh my god, 17 minutes. I didn't want this video to be too long. I'm gonna wrap up this video. If you enjoyed watching it, please make sure you give it a thumbs up, subscribe to my channel, A Coder Journey, and stay tuned for the next video in this series. Bye bye.